Okay, so the first thing is our essential question is what is the difference between the three subatomic particles? And if you're wondering, what are subatomic particles? Stay tuned.
Stay tuned. You will know that by the end of this slideshow.
Okay, so the first thing you need to know is what is an atom. So we know that we have matter in four different states: solid, liquid, gas, and plasma. But what is matter made up of? Well, the smallest unit into which an element can be divided and still keep its identity is called an atom. So that means if you have an element like oxygen and you broke it into teeny tiny pieces, the tiniest thing that is still called oxygen is called an oxygen atom. Or if you had, let's say, hydrogen and you broke it into tiny pieces, the smallest little piece that is still called hydrogen is a hydrogen atom.
So, within a single atom, we have what are called the subatomic particles. So, atoms are the smallest things that everything can be broken down into, but they even have some small things within them that go by three different names. They're called protons, electrons, and neutrons. The protons are found at the center of the atom. In this picture, they are the blue circles with the plus signs in them. They have a plus because they are positively charged. Electrons are, like in this picture, the smaller green circles with the negative symbols in them, showing they're negatively charged. And then finally, you have some neutrons also found in the center next to the protons, and they're just left blank. They have nothing in them because they have no charge. Sometimes that would be represented with a zero, but normally you'll just see them left blank.
And an easy way to remember this is protons start with a P, positive starts with a P, neutron starts with an N, no charge or neutral starts with an N. So these subatomic particles are found in different places within the atom. So the protons and neutrons, as you saw in the previous picture, are actually together in something called the nucleus. The nucleus is the center of the atom. It's super dense. That's where all the mass of an atom is. Whereas the electrons, the negative ones, orbit outside of the nucleus. So they're on the outside of the atom. They're kind of on their own.
So, when we talk about different types of atoms and elements, the very first thing that you should look for that is kind of the identifier for what type of atom it is the number of protons. And how many protons an atom has also tells you its atomic number. If you look at a couple of the pictures on this slide, you'll see in the top right hand corner, oxygen has a number 8 above it. Always, when you see a card like this and like it's shown on a periodic table, the number above the symbol, above the chemical symbol, will tell you the atomic number, the number of protons it has. Since an atom on its own is neutral, meaning it has no charge, however many protons it has that are positively charged has to be the same number of electrons. So, by knowing that an atom has, say, 8 protons, like oxygen does, you can also know straight away that it also has 8 electrons to balance out that charge.
So building off of this atomic number, we have things called elements. An element is just a substance that's made up of atoms with the same number of protons. So each element has a unique atomic number, just like how all of you have a unique student ID number that identifies you. Each element also has its own number. So, for example, carbon is an element, and all of its atoms, every single carbon atom has 6 protons. If it didn't have 6 protons, it is not carbon. So carbon's atomic number is 6. Anything related to it will be number 6. Atomic number of protons is number 6. If you were to say, oh, number 7, that would not be carbon, that would be nitrogen. If you say 8, that would be oxygen. So an element is a substance that has atoms with all the same protons, and atomic number is just like your student ID number.
Nice. I like that student ID number analogy. All right, the periodic table, a very handy tool in the field of chemistry, something that you will need to become very familiar with, is a table to help you organize all the different types of elements that there are out there. And what's super handy about this table is that you no longer have to memorize all the information about every single element because the table makes it super handy for you to figure that out. So the way it's arranged is by atomic order. So it's categorized by how many protons it has. You'll see that hydrogen is the smallest atom on the far left top hand because it has one proton. The second one would be helium, farther on the right. Then it jumps back to lithium is 3, to beryllium 4, and so on and so forth.
And like Ridgway was saying, you don't have to memorize all 118 if you just know how to read the periodic table of elements. So I could tell you that all the elements in the first blue column, hydrogen, lithium, sodium, which is Na, potassium, which is K, etc., all of those react with water. So I can tell you, without having to memorize it, that those ones in the first column, if I put them in water, could create an explosion.
So handy. I kind of want to have a little periodic table elements in my pocket. That'd be nice.
Indeed.
All right, so compounds, another term you need to be familiar with in chemistry. A compound is a substance that is made up of different types of atoms or elements bonded together. So one that you are very familiar with already, water, H2O, we've been talking about that a lot. That's a compound because it's made up of 2 hydrogen atoms and 1 oxygen atom all stuck together in that funny little Mickey Mouse looking molecule. You also might hear sometimes things like iron sulfide. That means that there are the elements iron and sulfur joined together to create the compound iron sulfide.
Okay, so when they're bonded together like this, we call that chemical bonding. And when you join atoms together, it forms new substances.
No way.
So the properties of the new compound is different from the original elements. So for example, something we're so familiar with, salt, table salt, NaCl, actually comes from 2 very different substances. It comes from sodium metal as well as chlorine gas, which is toxic. So things that you would not normally eat or even want to consume, when they come together, it forms a brand new substance with new characteristics. And so chemical bonding is a great way to make brand new things.
That's magical. So you're telling me the salt on the French fries that I get from In-N-Out, I have sodium metal and chlorine gas to thank for that.
Correct. Well, think chemical bonding.
Of course. All right. So coming back to electrons, one of the subatomic particles, the only electrons that you need to worry about are what we call the valence electrons. And these are just the electrons that are found in the outermost orbital. So going back to the picture of the atom, you have those black rings surrounding the nucleus. Just that outermost ring, so that farthest circle on the outside, is where the valence electrons are. So for example, lithium, you may have counted them already, has 3 electrons total, but only 1 in its outermost orbit, and so lithium only has 1 valence electron.
But if valence electrons are so important, then how am I going to memorize which elements have how many number of electrons? It seems like a lot to memorize.
Yeah, there's 118 elements, right? That's a lot.
What if only we had something we could reference?
If only.
You may be thinking, but recall the periodic table.
Right, that handy tool that I'm going to put in my pocket.
So, if you want to know the number of valence electrons each element has, you only have to look at the periodic table. So the periodic table, the column 1, they all have 1 valence electron. Column 2 only has 2 valence electrons. 3, 4, 5.
So simple.
Yeah, all the way to 8. And so all you have to do is remember this order. The ones in the middle that we left blank without numbers, they're exceptions, so we don't need to worry about that pattern. But just remember that 1, 2, 3, 4, 5, 6, 7, 8, and then you'll be able to figure out the element's valence electrons. So Ridgway, let's see how much you understand of this.
All right, I'm ready.
How
Quiz me.
many valence electrons does sodium, which is Na abbreviated, have?
Sodium, the one in the green box. So I see a number 11 on top of sodium. Is it 11?
So if you recall, 11 is its atomic number. So number of protons.
Right. That's right. You told me that it goes by the number of its group, the column that it's in. So it looks like sodium's actually just in the very first column. Does that mean that sodium has one valence electron?
Ding, ding, ding.
Oh,
Winner, winner, winner.
yes. Score.
Okay, your turn to quiz me.
All right, Miss G. Let's choose carbon. You see carbon in that green box right there? How many valence electrons does carbon have?
Well, since I know how to read the handy-dandy periodic table, and I know to skip the pink section because it doesn't follow the pattern, I just count there's 1 blue column, 2 blue column, 3 for the yellow column, and 4. Carbon is in the 4th one, so it must have 4 valence electrons.
Would you look at that? She got it right on the first shot. Nice job, Miss G.
Why, thank you. But why all this talk about valence electrons? Why do we even care about them?
Well, valence electrons are super important because they're the only electrons that are involved in chemical bonding. They actually are the ones that determine an atom's chemical properties. The other electrons in the inner circles don't even matter at all. It's just those ones on the outermost ring.
So the outermost ones will tell you if something is going to explode, if it's going to smell, if it's going to melt at a certain time. Valence electrons are the ones that does all of the chemical properties.
So, if you are an electron, really the biggest question that faces you in life is this: whether to bond or not to bond. Now, to help them answer this very tricky question, they want to consider what we call the octet rule. So, electrons follow this rule, which states that all atoms really want to have 8 valence electrons. Atoms all want to be super stable. In order to be stable, they have to have 8 on that outermost shell. So electrons are constantly seeking, as they come in contact with other elements, ways that they can complete that octet rule. And they can follow in, that can happen in 3 different ways. Number 1, they can gain an electron from another atom. That's kind of just a nicer way of saying stealing an electron from another atom. They could lose an electron by electing to give one up to another atom. Or, if they were a super sweet electron, they could even share, because of course sharing is caring. So if you had, for example, the bottom picture here, 2 chlorine atoms that are next to each other, chlorine both have 7 atoms on their outermost shell. But if they look at each other and say, hey, why don't we just both become stable and share one of our electrons to complete our octet rule? That would complete them and they would become stable.
On the other hand, if you look at the sodium and chlorine at the top, so Na and Cl, you can see that Na has 1, chlorine has 7, and so kind of the whole stealing idea, chlorine's going to take that 1 electron from sodium away from it so that it can be stable with 8.
So, wait a second, Miss G. So, the noble gases, I've heard a lot about them. They're the ones that are found in that far right group, that far right column in red. Why do people say that the noble gases are things that are non-reactive?
Well, it must have to do with their valence electrons because those are the ones that does the bonding. So I'm going to use the periodic table to figure out how many valence electrons things like helium, argon, neon all have. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I see that noble gases have 8 valence electrons already following that octet rule. So when they ask to bond or not to bond, they're not going to bond.
Because they're already stable.
Exactly.
They already have their complete set of 8. They're kind of the antisocial ones.
Indeed. All right. I hope you enjoyed our chemical bonding C notes.
Excellently done. Remember, you could always pause and go back to find anything that you forgot to write down. The end of your homework is to complete the C note summary on the bottom of the page, so please go ahead and start doing that. And good luck, and see you tomorrow.
Take care.